On the Invisibrake, it normally has a 4-pin connector, which I have located under here. In case I need one, I can pull it out. It's wired into the 6-pin connector that I use, which is this connector right here. Now, the advantage to this is that you can add a wire or two that aren't required in the 4-pin connector that really makes this job better. On this side, I have the breakaway switch, which essentially when you hook the cable to it, it pulls out and it applies the brake. So here's how the Invisibrake works. There's a control unit that sits under the driver's seat. It has 4 wires that go into it. It has a ground wire, a left signal, a right signal, and brake light combination, and a tail light. And it has 1 wire that comes out of it that goes to the battery that is where it gets its power from when it's operating. The wire that goes to the battery, which is a 20 amp wire and a 20 amp fuse, when that thing's running, it's a fairly powerful motor that creates vacuum for the booster cylinder and air pressure for the application cylinder that fits in the driver's compartment and actually pulls the brake pedal down. When the vehicle is in the tow mode, towed is being towed, in other words, you're supposed to keep the tail lights on. The tail lights feed 5 amps to the unit, and those 5 amps go back through that unit, come out through the 20 amp line to the battery to keep the battery charged. When you're in a heavy braking situation, you're drawing 15 or 20 amps to run that motor to do all the application process, create vacuum and create air pressure to do that. When you have extended periods of braking, you're only putting in 5 amps through the taillights circuit that comes to the control unit, but you're drawing 20 amps, 15 to 20 amps to run the unit. In excessive braking, you're going to deplete the supply of power in the battery, and when you go to start the car, when you get to your destination, the battery will be dead. So to prevent that, what I did was add a circuit, and I have a 20 amp circuit breaker on my motorhome that feeds through one of the 6-pin wires in the connection. It comes to this 20 amp fuse that keeps 20 amps constantly coming into this battery, so whenever it needs it, it gets 20 amps. When it applies, the flow goes the other way, or it comes from the motorhome, whichever, I don't know which way it goes, it doesn't make any difference, it gets there, and it draws 15 or 20 amps to operate the unit. But the advantage is it won't deplete the supply of power in the battery on your Toad. And so that's the added circuit that I put in. So it's fused here, it's circuit breaker connected at the motorhome, goes directly to the unit and keeps it from discharging the battery. So on the Invisibrake, there's probably about a 1.5 inch cylinder that's about this long that I fit in next to the driver's seat under this courtesy panel that is easily removed. You have one of these tools, you can slide the clips out, kind of lift it out from under here and pull it away from the locking lip over here, and just pull it out or pull it back, and it'll come out pretty easily. That allows you to put the cylinder in under here, and from the cylinder is a cable that goes down under the rug and back up to the pulley right there, and that's what actuates the brake. And that's operated with air pressure that's created by the control unit. On the other side is the cable that comes from the air cylinder actuator that pulls the brake down. So when you're driving along, it works freely, but when you actuate it, it pulls the brake pedal down as you would normally have it do in a braking condition. The Invisibrake control unit fits pretty neatly underneath the driver's seat, although you do have to remove the bracket that holds the wiring harness in for the seat so that there's room to get it in, otherwise they hit each other, and you kind of got to get it in there, wiggle in there, because when the seat moves back and forward, some of these connecting rods that are in here move up and down, and they will bang into the thing. So there's just enough room under the 2015 Jeep Wrangler under the seat. If you take that bracket out, which is kind of hard, it's in there with a pretty strong rivet to get out, but once you get it out, it fits in there really neatly. I don't have it tied down, but it doesn't make any noise or move around or whatever. So since I decided to wire this differently and not use the parking lights to indicate that the vehicle's being towed, which required a relay so that it would stop the flow of electricity from the car's braking circuit to the backflow through that circuit to the bus circuit, I added a switch. And so there's no relay, but I do have to remember that in this position, it's normal position, so the brake lights work. But in this position, you pull it out and push it up, it takes the power from the brake light switch away from the car circuit and sends that power to the monitoring light up in the bus, and it allows me to know when the brake is applied, because now instead of turning the brake lights on, it turns the light on in the bus. And so every time I hook up, the one thing I do have to remember to do is to flip the switch in the up position. Normally it's always down. It's just a 2-position switch, and it locks so that you can't accidentally move it in the wrong direction. So the coach has amber turn signals that operate independently of the brake lights. We have that situation. There's a relay that you can buy that that sends the turn signals into the 4-wire connecting cable. So online you can buy this Hopkins electronic power taillight converter, which actually has an amplifier in it, so it increases the signal going to the towed vehicle. And it also has a double protect safety on it. I recommend buying the more expensive one. They have a cheap one. I hooked that one up and burned it out before I even got a chance to use it. So I would buy this, but what this does essentially is it takes your amber turn signals and converts them into a two filament bulb for a combination brake light and turn signal use, like there is in the back of a Jeep Wrangler. And then one other thing is, one of my other videos, I added this switch here. So when I flip this switch up, it actually turns the brake lights on. And so I can come back here and check my brake lights, which you can see are on, which also applies the brake in the car, the towed vehicle, and I can check all that without having anyone help me, simply by flipping that switch. And it's really a convenient way to have this operated. The last thing you'll need to add is the diodes that go between the brake lights in the car that have power coming in from the wire from the tow vehicle that keeps the power from feeding back into the electrical system on the towed. And so at each of the brake lights, you take them out on this vehicle and put in a little plug-in relay. It unplugs, you unplug the wiring harness from the light, you simply plug the wiring harness into one end of the relay, and the other end of the diode and relay, you plug in the light, and it's all plug and play. Also from Hopkins. It's vehicle specific, by the way, so you have to get it for the right vehicle.